Alright, let's do the geounique. So, I have a convex polygon and I want a hexagon inside it with at least that area. Okay. So, if P is... Let's say P is an n-gon. I'm going to first try to figure out where that 3/4 is coming from. So if P is an n-gon, that 3/4 is nowhere near sharp, because if I have a triangle, you can just lop off little bits at the end. And then it's just kind of like, okay, well, n equals 3 can get close to 1. Actually, okay, for n at most 6, you can just get close to 1. Because all you have to do is like cut off little guys. Yeah, okay, so for n at less than or equal to 6, the problem is dumb. Okay. So we'll assume n is at least 7. Okay, on the flip side, suppose I have like, yeah, for n less than or equal to 6, you just clip corners. Now for n, on the other hand, maybe suppose I have something that's large, so like, you take n very large and you get approximately a circle. Yeah, not a regular hexagon, just hexagon. If I have approximately a circle, I mean, the max area should be the regular one. So this is motivation only because I'm trying to get a sense of how good that constant 3/4 is. This is like n goes to infinity, quote unquote. And then I can do this, and my area will be √3/4 times the radius squared times 6 divided by pi times r squared. So this is 3√3/2 pi? Okay, so now let's do some mental arithmetic. So, for no reason at all, I happen to know the decimal approximation for √3 is 1.732. And we'll just say pi is 3.14. So this is 5.196 over 6.28, which is definitely more than 3/4. It's approximately equal to 7... Wait, what? This is more than 3/4, right? Oh, I'm just silly. Okay, I was 0.8. Sorry, I was like, why is it not? Okay, 0.80. Oh, I'm really slowing down. It's relative. No, shoot, 82. Okay, I'll just take a shit. Okay, yeah, about 0.82. So it's definitely more than 3/4. So if my n-gon is close to, alright, that's fine. So where's the 3/4 gonna come from? Is there an example that gives you close to? Okay. $12 Yeah, do I get equality to $12? So if I have a 12, oh, I see. Because I can refine it by like getting. Okay, so if I just take a 12-gon, I took a circle, which is kind of dumb because it's, you can cut down the area of the ambient space. Does 12-gon actually give you exactly 3/4? Because if so, I'm really scared of this problem now. And the shape you end up, oh geez, it's actually going to be exactly, that 3/4 is going to be sharp. Oh no. Oh no. Is it actually 1 to 3? I think it is actually exactly 1 to 3. Because if I look at this shape here, no, it's not. Wait, what? Okay, let me do the calculation. So if I have unit radius, 1, this is 30 degrees, so this is a half. But this is root 3. No, it isn't. Oh, jeez, scared the heck out of me. So it'll be some irrational number that is not exactly... I agree it could be an ellipse. Right now I'm just kind of doing the simplest cases to try to get a sense of where that 3/4 is coming from. I agree, yeah, I agree there's a strong chance that 3/4 happens to be what you can actually prove and that you won't be able to get the optimal constant. But it's good to poke around, I think, to see if you can get it. Because if you can get something that achieves the optimal constant, you want to know that like right from the start, because it will immediately rule out a lot of things. Like anything that doesn't work for the equality case, you throw away immediately, and you instead model your approach around that. I'm not finding something right now that gets to 3/4. We might want to look a bit more, but if we can't find anything that gets 3/4, then there's a chance it's one of those problems where yeah, 3/4 happens to be what you can prove and not optimal, and then in that case, you know, your data is a little worse, but whatever. You still have to do that problem. Okay, I got so scared for a moment though. I was like, is that actually going to be a pi bait? Doesn't look like it's a positive correlation. Yeah, well, as you take n to infinity, the number goes, the proportion goes, no, wait, what am I doing? Did I do this the wrong way? N to infinity, you want the ambient to be larger. I flipped it. Okay. So I have reason. So a 12 gon will definitely do worse than a circle. Okay, I'm just being silly. Circle should be like the best in some sense. If it's an ellipse, then you can reduce to a circle, I think, by stretching in a certain way. Yeah, it could be that, and it's not regular. Like we've been doing regular, but the best examples might be when it's 6 divides n. How can you prove that it's optimal? We don't have a proof, and a proof would I think be beyond the scope of Olympiad anyways, because it would be too. It's too analytic. It's not the kind of thing that should be on a high school contest if you're to prove that a circle is optimal, but it's definitely the right intuition, I think, that you want. Okay, well we can try some irregular polygons. The motivation being that maybe for really symmetric things, a circle will be better in the sense that like circle will beat like a 30 gon, which will beat an 18 gon, which will beat a 12 gon. But if I make it irregular, you can force the hexagon to sort of behave in strange ways, and like in asymmetric ways. So I'm trying to decide, what about an obtuse triangle? Let me see. I'm gonna try 8 gon and see, 8. Do you guys want to do 8 or 9 or 7 first? I don't know which one I want to try first. Nine gives around 0.84. Okay, thanks for the tip. What does 8 do? I'm gonna do 8 then, because someone did 9 for me. So... No, this isn't good though, because it actually takes up... There's like less clipped off. You only get like these little 2 triangles clipped off. Yeah, that's not good. It is gonna be... I don't know what it is, but it's gonna be worse than the other one, I think. Yeah, sort of like rounded. Um, there's a theorem. I'll put it this way. There's a theorem that if you have... Sorry, something just occurred to me. P being a polygon shouldn't matter because you can approximate any... Oh my god. I got duped. Sorry. Sorry guys, I really got duped. Realization. P being convex polygon versus convex curve shouldn't matter. because you can approximate P with a convex curve well with polygons anyway. Sorry, I totally didn't notice this. I'm sorry, guys. We got baited. That means that n-gon shouldn't really matter. So what happens is, like, I claim that if the problem is true for convex polygons, it is also true for convex curves. Like, you know, oh, I don't know if that's actually convex. Pretend that's convex. And the reason is that, oh, that's not actually convex because of the region here, but whatever. Um, Here, let me just do like something like this. And the reason is that you can approximate a convex curve like this by a polygon anyways. Like I can draw a polygon with a lot of sides. You know, it's sort of like the same reason I could have approximated a circle with a polygon. Actually, any convex curve I can approximate by a convex polygon. And what that means is if the problem is true for a convex polygon, it is probably also going to be true for just convex curve, period. Like the fact that it was a polygon shouldn't matter, and it's probably only there because it's a high school contest and you don't want to define the word convex curve, so you just say polygon. What that means is that us looking at 8 gods and 9 gods or something is probably a red herring. Like it's probably, well, there's a chance that that sort of makes your proof easier, but I think it's more likely that it means we're going the wrong way. Like it um I feel like it means we're going the wrong way. Because like it means that somehow the problem had a natural interpretation that didn't refer to a number of vertices, and so if you're trying to use too much the fact that there's so and so number of vertices, it's not great. Okay, so what that means is I'm going to, until I see a reason that the vertices matter, which is possible. I'm not saying it's impossible, but for now I'm going to imagine that P is actually just like some convex blob, and I want to put a polygon inside it that I want to put a hexagon inside that I want to put a hexagon inside that tries to get as much of the area as possible. All right, how can I do that? Equality cusp must be a polygon, otherwise they would say greater than 3/4 strictly. No, I don't agree with this. I think it's completely reasonable to say at least 3/4, even if equality can occur. I just, do you think? I mean, here's the problem. Like, we don't have an equality case that's a polygon. we haven't found one yet that gets you 3/4. Is there one that I'm not seeing? Okay, let's think about it this way then. If you think there's an equality case, which is possible, let's look for it. Well, we'll go the other way around and say, suppose I have a hexagon and I want it to have 3/4 the area of some ambient guy. What would 3/4 mean? That means I need to divide this guy into thirds and then copy a third of it. So I don't know. That's stupid. I don't like that. Dun, dun, dun. What would I do that's not a circle? Yeah, so far I don't have a reason to believe that there should be something that's better. I'm curious what happens if can I like do something like that? Like, can I draw a big... So I'm trying to imagine like a 12-gon where, like a 12-gon that looks something like this, where the sides alternate in some weird way. And then you like try to take the midpoints or something. I'm not sure. What was that? The fitness gram pacer test? I'm so confused. After this, let's try a cubic. Oh lord. Why can't you just stretch two vertices really far in opposite directions? What do you mean by that? Like vertices of P to create more empty space. Well, I mean, if you had two far away vertices, can't you just, like if I had something like that, then you just end up taking like, I guess that's a reason hexagon might be the right, like, so I was a little wondering why it was a hexagon in particular versus any other thing, but that may be a reason why. If I stretch two vertices very far away, then you can get close to 1 by taking these 6. Um, okay, let me go back to this purple egg. I'm trying to think, like, how am I going to get area into this picture? I'm trying to think what happens if I... Suppose I pick 6 random points, and maybe I can even do that, like, probabilistic random, like, just... what. So if I pick 6 random points, like, how can I get a handle on that area? There's, like, some area there, I don't really know how to control it. Um... Mm, hmm. Sine 60 is a half, right? I'm trying to think. Sine 30 is a moment. Okay. Can you resolve past results that seem useful? I don't think we've said very much that's an actual result. I think we're just trying heuristical things. I think the main thing I have is that I now believe the number of vertices of P is probably unimportant because the problem seems to be true for a general convex curve. Let's triangle at least half area. Yeah, it might be worth trying to think about, like, I'm still confused the problems about a hexagon and not about a triangle, for example. Yes, sine 60 is root 3 over 2. I agree. This has been pointed out a few times to me. So, if, what if I just have a triangle? And if you're in circle, it should be the regular one. If you're in a regular polygon, I'm not liking this. If you have a really tall hexagon, if I have a very tall X shape, let me answer that for both triangle and hexagon actually, because I'm curious. If I have a tall X shape, the hexagon, well, you would align it like something like that. If I have a triangle, I'm not sure actually. So I wonder if maybe what I want to think about is, oh lord, what is that? Can you do this after the test? OHE5? Well, there's a couple of problems, other problems in the queue. So maybe. I mean, okay, if you have a long ellipse, you can shear it to a circle anyways. Like you can stretch, like you can apply a shear transformation until the very long ellipse becomes a circle. I almost wonder if I should just like, Oh my god, someone submitted an ad break. Okay, I'm gonna let's take a quick 30-second ad break. I will, get up and walk around so that my blood doesn't all pool. Oh, well, I'll be back in 30 seconds. Okay. Okay, Ankon says he suggests looking at union. A hexagon is a union of two quadrilaterals. So, let's see. Okay, I want to draw another egg. I really feel like I'm missing something. I wanted to, so that's the longest segment I've drawn. Um, I like longest segment in some ways. I think the main thing that complicates it is that, as I said, if you can shear transform the entire problem. For example, I can double all the x coordinates, say just stretch everything in one direction. That shear transformation doesn't affect area ratios. So there's a sense in which Euclidean longest segment might not be important because I could have sheared it so that it wasn't as long as possible. I'm not totally sure if that heuristic is solid enough. But we can try it. Like if I take a longest segment, then everything lies in here. Oh my god. Oh man. Yeah. I don't think it's obviously wrong. I think it's maybe okay. It's just like, I don't understand at all how you get areas into the picture. It's just like, why are there areas involved? Like, like, nah. Yeah, area does seem easier to think about with polygons. I guess if I want to use a generic convex curve and still have an area argument that's like reasonably integrate. I considered this briefly and was like, no way, right? But maybe. Um, the problem is that you need the convex condition because if you don't have convex, it's definitely not going to be true. But I was thinking this thing where I take like one point inside and like take a sweeper and then like somehow randomly pick the 6 angles, but I just don't know how you would compute the area if you try to do that. One half AB sine C. If it's a polygon, sure. I mean, like I want to do something about like that black region, like that. I want to be able to say something about it, and I can't see how I'm going to do. So AB's, you can choose a quad with side AB. Fake geo like this. Alright, I'm gonna follow the quadrilateral suggestion because I think that's better than what I have so far. Can I make a fake geo unit? It's the hybrid geo unit. Yeah, so in fact, maybe you're like, okay, take a long segment and maybe I'll even shear it so that it's in here. And then I have some points that are may or may not be inside this circle. No, let me just draw a convex arc. So the x-coordinates are all sort of distinct. Do you guys want to try the integral thing? I actually want to try the integral thing now. Do you guys want to try the integral thing? Yes? Alright, let's just try it. And if it works, it'll be hilarious. And if not, I want to see why it doesn't work. So what we're going to do is I'm going to start by taking, say, some maximal segment. Alright, the reason I want to take this maximal segment is because I want to integrate, so I want a base. And the idea is I'm going to pick two random points, x and, well, s1, s2. This is some function f with endpoints, f from 0, 1 to r plus, which is convex, whatever that means. So it satisfies like Jensen's inequality. Oh, we could use the convex. And so the area is fixed, right? The area is, oh, here's the thought. Here's a thought. What if I just divide the areas into roughly thirds? If I pick S1 and S2 so that it's 1/3, is it true that I get enough? Because it seems like I should get enough. I feel like it should be enough. So I want to pick F such that S1 and, let's just call it A and B, such that, like, the area, we're going to assume without loss of generality, the integral of ft from 0 to 1 is 1. Or, actually, let's do 3. And I really feel like if I divide this into 1, 1, and 1... No, that's not. No. There's no way this is true. Okay, scratch that. I just need to... I'm trying to decide how to pick f and... Let me imagine some extreme cases. So if I have roughly a circle, you actually wanted to pick the hexig something, but that's not quite what's happening here. On the other hand, suppose I have a thing that looks roughly like this mountain. Okay, so you just have like something like that. Then the points that you would want to pick are like here and here. Like that. So you grab most of that area. So it's sort of like I want the point, I want to cut at... What do you guys think? I'm imagining there's like a tangent. There's like a tangent here and like a tangent here or something. So I can certainly pick A and B such that the function f is increasing at near 0 and decreasing near 1. And so like the derivative of f prime, because it's convex, it just goes like that. So here it's like increasing, and here it's decreasing, and I want to pick... I probably want to pick it based on where the derivative is. Yeah, maybe I want to take the point where, okay, now like this here, it could be like plus infinity. There's a quote unquote slope of plus infinity here and a quote unquote slope of minus infinity here. And so I don't know. It's like, how do I pick the 2 points? I feel like the 3/4 bound, we've seen the 3/4 bound is just not that good. It's like for a semicircle, you can get, wait, what was the number we got? Like 0.8? So, okay, it's not that bad either. How do I get 3/4? Well, okay. Actually, it's not enough to inspect the derivative at a, I think. Because you can imagine, like, Oh, man. I think if it was a quadrilateral, I would definitely want to pick... So here's a thought. If you pick the... Because it's convex, there's a local max. Like a point up here. If you pick here, that's 1/2. You get a bound of 1/2 always, and that bound is sort of sharp because it could be a rectangle. So actually, we were trying to look at quadrilateral, but I wonder whether we want to look at a triangle instead. Well, okay, what if I just repeat that? If I repeat that here... Hang on, okay, this is doing something. Is that one segment of the polygon? No, it's a segment in P. So what we're imagining is like P is some egg shape, and then we cut it in half somehow, and I don't know how the how is, but hang on, I like this idea actually. If I have a curve, if I have a segment and a curve, then hang on. Do calc. I don't think I'm not actually literally doing calc. Like I'm not actually using whatchamacallit, integral. I think my sentiment is more something along the lines of we should have an x-axis is what I would describe this approach as. I think it's unlikely you will be able to actually get calculus. Yeah, that's what I thought. It's like I have a triangle, right? So suppose I pick a triangle. I have a blob. If I can pick a triangle that's at least half the area, then I can get at least half of the remaining area like that. So suppose I have like, A, B, C left over. If I pick the point here with the highest altitude, that's like half A. So actually all I need is a triangle that has at least half the area. That should be really doable, I think. I really think you should be able to do that. You can't always find a triangle with half area? Seriously? I can't? I can't? No! Why not? Um, if it's a circle, can I get half? Oh yeah, you probably can't always get half. I agree, actually. Well, hmm, mm. Circle, because the equilateral triangle is half the hexagon. If it's a bowling pin, you can't get half. Okay, fine. Nonetheless, suppose I did follow a quadrilateral strategy, alright? So if I have a quadrilateral, I can get at least half the area. So at least half here. And then there's like up to half split between these two things, like a quarter. And then I could get 1/8. So I don't know how good that is. But I feel like, is it really true? If I have a circle, can I get half of it by doing a triangle? Well, half is a little bit of a misnomer. A circle can't get half triangle. Sad. Okay, then this is not great. Triangle 3/8, improvise somehow. Okay. I really like this 1/2 thing, because this is the first time I actually have anything that's like remotely reasonable. But half a circle. Yeah, so you can get like, I can get 5/8 if... Okay, how about this? Well, okay, let me leave this picture up, because I think this picture will matter a lot. But it's not exactly the way to go, I think. So what if I took this and then... Well, I guess the basic idea is that now, if I pick 2 points, A and B, then my bound on the area is basically like the hexagon formed by these tangents. Very roughly. And so, well, what is the correct thing in a hexagon? Like if I... it is actually slope 1/2, right? Which is good because it's at least rational. So maybe I take this one to be... So I'm curious now. If I take this one to be slope 1/2, and this to be the point where the slope is minus 1/2, what is my bound? Do I get 3/4? If so, I'm very happy. If I mean, maybe that's way too optimistic. So my thing is like that. I think the answer is no. I think this is not good enough. But I want to see why it's not. Is this a perfect? No, it's just you imagine there's a blob and then you take the points on the curve for which the slope is 1/2 versus minus 1/2, and then like, do your best. Like somehow when I took the slope to be 0, it was amazing, and just like sort of did exactly what I needed it to do. And I'm trying to see why that won't work here. I feel like this won't work because I can trick it into picking a bad point. You do the halfway? No, oh, never mind. Okay. One reason I do kind of like this is because it will actually... Okay, actually, first, if I'm in a regular hexagon, is this the thing I want? If it's like actually a circle, do I get the... Yeah, I had the 5/8 earlier. Um, okay. Before I keep going, can someone do a MathCounts calculation for me? Pretend this is like an FTW problem. Uh, what is the area of the orange quadrilateral versus the green quadrilateral in this figure that is nicely truncated? I want to see what it is. So if the green one is area 1, then this is... It's 3-2-1. Right? Right? Am I crazy? The green is actually exactly 3/4 of the orange one. Am I right? So I really believe this is like, okay. Wait. I'm really excited now because now we have a reason why it might be 3/4. Wait. Okay. Now I'm excited. Let's go after this. So 3/4. Okay. Now I think I know where 3/4 is coming from, guys. Let's do it. Okay. Okay. Well, I need some numbers for this. A, B, and C. And let's call this X and this one Y. All right. And well, because the slope is at least 1/2, I have some inequalities on X and Y. Um, so the slope here is always bigger than 1/2. Is bigger than 1/2. So A is, maybe that doesn't even matter. Is it X greater than A over 2? Doesn't feel like a very good bound though. Like somehow I want to show the Oh, this is not looking as good. The circle wasn't sharp anyways. Well, no, but Oh no, wait, I'm being stupid. Okay, here. The point is that because of convexity, the red curve has to lie within the orange guy, right? Like the red curve has to lie inside the orange guy. Period. Slope doesn't work along long half of ellipse. Yeah, I agree. Wait, what? No, I'm picking it such that, like, I picked the 0, 1 segment to be one such that it was contained within the two vertical lines. Like it doesn't have a, it doesn't balloon out. So the claim is that if I, the general claim that I'm really hoping is true because it will solve this problem, is that if I have a house-shaped picture like this, where this has slope plus infinity, uh, this has slope 1/2. Ah, that's too bright to see. Some of these colors are useless because they're just not visible. Okay, this is plus infinity, plus 1/2, slope minus 1/2, slope minus infinity. And my hope is that if I pick any point on, like, here and here, the area will be at least 3/4. Maybe this isn't actually looking very good. Is that true? That looks like, no, that looks like it should be true. And if it's true, I should just be able to bash it out, right? Yeah, I mean the orange hexagon is the sharp one. Um, wait, am I crazy? Am I a crazy person? Um, I really think this is supposed to work because it really had the quality case in all the right places. The house can have no walls. Oh, shoot. Good point. The house could not have any walls, and then your green thing would. House. No! It's the walls could have height 0, and then you're in trouble. Ah, frick. No. The house could not have walls, and if you don't have walls, you're in trouble. You need to pick a different point. So, minimize green area. And it should be 3/4. Well, the point is you start with a curve, and I need to build a house around the curve somehow. And then, but I need to pick the points first. Oh, that's, frick. This picture here is so important though, I think, because it actually gets you the 3/4. This sort of gives you a reason where 3/4 comes from. The idea is that whatever this thing is, I want to trap it inside. I'll call it a house. Like I want to put a house around it, such in so and so way. So I think slope 1/2 and slope minus 1/2 is the wrong thing to. It's not correct that my goal is to have slope exactly plus 1/2 and plus minus 1/2. I'm trying to see what the goal should be. I need to pick it somehow, and I'm trying to see what it is. Man, I got really excited. I thought 1/2 minus 1/2 was gonna be it, because those are rational numbers, but that's not correct. Because you can... Yeah, basically what I want to do is I want to pick 2 points, and then, like, draw 2 tangents, and then bound things by the tangent. Yeah, this 3/4, this is where the... I'm absolutely convinced this is where the 3/4 is coming from. And what I want to do is I want to show... Alright, let me use different names. I want to show there's 2 points, x1 and x2, such that when I take f prime of x1 and f prime, you take these 2 tangent lines, and the I don't know, man. Do I just write this out? I don't know what to say. Hmm. What way do I have to pick those 2 points? Like if it's a circle, we know it's like 1/3 and 2/3. I want something that's an analog of that for here, but I don't know what it is. Like, oh. Oh no. It was looking so good. Can you not? See, the reason 1/2 was good, yeah, 1/4 and 3/4 sounds too naive, well, actually, can you just pick 1/4 and 3/4? I really hope not. That would be really stupid. Uh, oh man, I really thought we had it. See, the problem is I actually know exactly what I'm supposed to do if it's rather than picking 2 points, I just pick 1 point. If you want to pick 1 point, you pick the local max, and you get a rectangle, and that's best possible. But I'm very confused what I'm supposed to do with if I'm supposed to pick 2 points. It's like you want them to be, yeah, and in well, it gives exactly 1/2 when it's if you do rectangle, and then it's actually exactly sharp. Bye 3VT. See you next time. But I don't know what it's supposed to be for 2 points. Because I thought it was going to be, oh yeah, pick plus one half and pick minus one half. But then your house, if your curve is picked in a bad way, then you get a house with no walls. And if you have a house with no walls, then you're kind of dead. Um. Oh wait, is he saying when the curve is a rectangle, I get 3/4? No, it's not right. Frick. No, we are so close. I think I have the right 3/4. Maybe I'm thinking about it the wrong way, actually. It's possible. No, this has to be. Maybe I should pick a triangle and then take the tangents to that triangle somehow. So I take the ambient curve. So you have a polygon, and then I pick like 3 points, and then take like, because I think this is the right 3/4, but maybe picking 2 points is the wrong thing to look at. So maybe what I do is I pick 3 points like that somehow. I'm not sure how, but I pick 3 points that do that somehow, and then for each of these, I can get at least half of them. Not or you can get at least half, but I think you can be able to do better than one half. So by mean value theorem, something like that, and then you try to use the fact that there's some trapezoids in play to get a better bound. I don't know quite what that would look like. Actually, maybe it just works. Maybe I pick an equilateral triangle as the tangents. I pick an equilateral triangle as the tangents. And then... Wait, is that just... No way. No way. No, but then I need to do something about that inner area. Yeah. Well, okay, if you have a convex curve, the tangent lines will enclose it. Like I can pick it this way. It's just it probably is not always correct. It's just I'm really confused about this thing of I think the shape of the solution has to look something like this. Like I take some tangents that are like this, but I don't know how to pick the tangents. And I think the only thing we know right now is if you have 2 points fixed and you need to pick a third point on a curve, you always pick the flat point, the local maximum. And that will give you one half, which is best possible. But we're picking several points, and I don't know how to pick them. Like one approach is this thing we've been doing where if you have zero, if you cut it in half somehow, and then try to pick 2 points on a curve. The other is I can try to draw a triangle and then pick 3 points on a curve, but I don't see either of these doing great things right now. And the 3/4 is actually sharp with this approach because when you have a circle, you have like two hexagons inscribed inside each other, and that will give you 3/4. So if I want to go a route like this, I can't lose any precision. Like I need to hit it on the head, which makes my life easier because actually I need to. It rules out a lot of things, but I'm a little unhappy. It's just I don't know how to pick 2 points, but I don't know how to pick. So if you get half a 12 gone this way, what if you just pick every other point? Yeah, oh, I see. If I get half a or no, wait, no. What 12 gone is here? We're picking the vertices of the green shape to be a hexagon. Yeah, yeah. Hmm. Okay, here's another idea I just had. What if, rather than me like trying to blindly throw junk at the wall, what if I say instead, I guess I was thinking we'd pick another point bounded by each pair of adjacent tangents between each. Maybe? But anyways, okay. Here's an idea I just had. Right now I'm just kind of throwing stuff at the wall. What if I just say, okay, what I'm gonna do is I'm gonna use this two picture thing, and I'm gonna pick 2 points which are optimal. I'm actually going to assume that it's optimal. And what that means is if I have this x1 and x2, and if I jiggle each of them by a little bit, the area should either stay the same or go down. Well, actually it should go down. And that will give me some constraints, and I can see if those constraints are good enough to give me what I want. So for example, if I have a configuration like this, and I replaced x1 with some x1 minus epsilon, what would happen? It means that I'm going to move this picture down for a moment. So let's give me these names. This is called H1 and H2. So if I change the area, if I change by epsilon, then what happens to the area? The area changes. Let me do plus epsilon actually. That's probably more customary. If I change by a small epsilon, then the area changes by so it goes up. The triangle increases by 1/2 epsilon h1. Is that a hint for my problem? Oh no, that's what 2008 too. Yes, that's a great hint. Because part B exists, it rules out many approaches for part A. So epsilon 1, and then but then the other area changes by epsilon times. Wait, sorry, I'm being stupid. Okay. Let me just do this properly. So if I change my small epsilon, the new area of the two left regions, is 1/2 x1 plus epsilon times h1 plus epsilon f prime x1. That's the area of the triangle. And the area of the quadrilateral is 1/2. Okay, it's a trapezoid, so it's like x2 minus x1 minus epsilon here. And then this guy is... Let me write them in the same order for consistency. x2 minus x1 minus epsilon. And then the other one is h1 plus h2 plus epsilon f prime x1. And okay, so the terms with epsilon equals 0 will be the same. And then maximize one point first and maximize the other one? No. What I'm gonna maximize both simultaneously, and the reason I can do that is because the function that takes I'm looking at a function that takes ordered pairs x1 x2 from 0 1 squared into R, the objective function, because the left hand side is a compact set. There's a maximum. Possibly at the endpoints, but the endpoints suck. So I'm going to say look at a local max. If it turns out to be at the endpoints, something's wrong, I think, because you can... Yeah, so I'm not maximizing one and then the other. I'm actually maximizing both simultaneously, and this is a thing I can do because of compactness. Okay, so the epsilon term is... okay, so it's the epsilon coefficient must vanish, and it's equal to h1 plus x1 times f prime of x1, and then plus x2 minus x1. Okay, so this is actually x2. And then minus, okay, so minus h2. Wait, really? Okay, so when this happens, actually, apparently it just means that these two are parallel, which is not what I expected the result to be. Why, really? I mean, it's true. Really? That's the result? Heh. Okay, I'll take it. And then the other one's parallel. So, um, I mean, it makes sense, but it's so not intuitive. Or okay, maybe my intuition's not as good. It's a big surprise to me. That was not what I expected the result to end up being. So okay, fine. What that means is, let's draw the house again. The house might not even... And this time, the way it's defined is that you take this purple line and that purple line. These are like parallel. And the green hexagon is this dude. So now even if the house has no walls, I'm fine. And we have reason to believe this is sort of what we want because I sort of picked it optimally. And the question is that green guy at least 3/4 of the house, the yellow house? Yeah, I agree it makes sense in the diagram. It's, you look at this like, yep, that is actually what happens. And okay. So is the green guy 3/4 of the yellow guy? At least? Maybe? Hope? Uh, is that true? I have no idea whether that's true. I hope it's true, because I'm running out of ideas. Is it true? Does someone want to do this calculation for me? Because I'm really confused. Okay, well, it's true if the okay, to be clear, this house picture is a little misleading because the house could be the house might have a messed up roof. Like the roof, that roof might be like that or something. So it doesn't have to be parallel. Jeez, this is so annoying, actually. In the equality case, okay, I have no idea. How would you even do? If it's true, it should be easy to do, and if it's not true, then I'm sad. Oh no. What did I get myself into? No! No! Someone please tell me this works. I'm like ready to move on to the... If you think the stream has good quotes, you should clip them so I don't have to clip them myself later because I never do. 2G6. Well, I think this one is much more humane than the 2017 G6. I think this diagram is also off. I think that purple line is not actually parallel. So I'm having a hard time telling what's going on. Let's try that again. Oh, welcome back, Brian's DJK. We're currently doing another G6 that's a little better than the 2017 G6, which is not saying much, but this time we actually feel like we're going somewhere. Last time I felt like it was just like I never knew whether anything I did was like even remotely correct. Oh my lord. I don't want to do this last calculation. My video buffers every time I come on this stream. Oh, I'm sorry. Let me check what resolution I'm streaming at. I think it should be 720. I thought I changed it. Yeah, 1280 by 720. So, unfortunately, I don't think I can decrease it much more than that. Okay. Does someone want to do this calculation for me? Because I don't know how to do it. Uh, uh. In the equality case, jeez, that's actually so annoying. Um, mhm. I mean, we think this claim is probably true, right? Is that the feeling? It's just I don't know how I'm supposed to do this calculation. Do I just bite the bullet and like start bashing? I mean, we can draw the two altitudes again. All right, I'm gonna bite the bullet. I think this claim is our best hope at solving the problem, so it'd be silly for me to give up now. Okay, stretch. This is A. Oh, does it fail? It fails if one of the roofs is vertical. Does it? Oh, I guess you can. Okay. Okay. All right. Well, that's a horizontal roof. Oops. uh. Well, I think horizontal roof was meant. I see. No, no, no. Like the purple thing is supposed to hit the other yellow dude. Wait, this doesn't make sense. That picture doesn't make sense. Like it's supposed to hit the other. Okay. Well, sorry. I just messed up in two different ways. Sorry. So the claim is if one of the roofs is very near vertical, it will also fail. And what happens when that happens is this is near vertical, and then the other roof can do whatever. And then like whatever. So we draw a purple segment that looks like that. Does it fail? Wait, does it fail? Why does it fail? I'm not seeing why. Because there is a condition that the purple rays are supposed to hit the other roof by like construction. Like it's not okay for the purple ray to hit a wall. Um Maybe one roof vertical, one roof horizontal. Well, see, here's my problem. Like, because of the way I constructed things, these are genuine. Oh wow, it's almost 11. These are genuine local mins and maxes. It would basically degenerate into a rectangle. Okay, let me try that. So the degenerate counterexample you're proposing is that I have something that basically looks like this. And I think in that case, the algorithm does... Well, it just doesn't apply, right? Because this thing is supposed to hit the purple roof and doesn't. Well, okay. What I can... Alright, if I want to steelman this argument, what I can do is make one of the vertical walls very small. Make this one like that. Make this one just slightly slanted. And then, okay. And then this purple thing would barely hit that wall. And this one would go like that. Okay, yep, yeah, I'll do it. I'll do it. Alright, good game. G. Oh man. And that was actually a... Oh man. And in this case, we still picked the wrong quadrilateral because we should have really picked like this guy and this guy. But no, like this is a counterexample, right? Wait, now I'm a little confused. Wait, what's the 1/4 and 3/4 thing? You think 1/4 and choosing x equals 1/4 and y equals... Oh, that's not bad. We can try that too. Yeah, that just feels... Okay, let's give that a shot, because this house model isn't quite working. I thought that if I picked a local max, we would definitely be okay, because it's like literally a local max, so it's probably pretty good. But apparently that's not good enough either. So let's try 1/4, 3/4. Yeah, why did I pick 1/3, 2/3 earlier, actually? No, that I'm thinking back. I picked 1/3, 2/3 for no reason. That was just stupid. Because, I mean, the equality case was not that. So let's try again. One last try. So curve 0, 1, and then I take 1/4 and 3/4 to get some shape, some green thing. We get a new house. This time the house is contrived in some way. I thought we had a counterexample to this. It feels like the counterexample for 1/3, 2/3 should equally well apply here. What was it? It was a rectangle. Are you serious? Okay, then I'm just dumb. Then I just really messed up because 1/3, 2/3 wasn't correct for an equality case with a circle anyways. So Okay, well, in that case, I'm going to be really upset if this works, because I was so excited about the derivatives. Oh my god, this is going to work. Because if this works, there's no computation, right? It's just... Okay, so there's a 1/4, and then there's like a height h1. Uh, and there's a height h2. And you know the area of the green guy explicitly, so I want to bound the area of the orange guy. The orange guy, the orange guy is formed by... How do I want to dissect the orange guy? I was trying to find a dissection proof. What if I just like hit it with a hammer until it dies? How about that? Okay. So y1, h1, y2, h2. Um, the length of this guy here is something, and then there's some other. Oh, jeez. Okay, this is annoying. I mean, oh, it doesn't work for right angle triangle. Sad. Like the if the yellow guy is a right angle triangle. Yeah, that's pretty bad. Right angled on one of the walls. Oh, wait, so just take a literal right triangle? And then if you take 1/4 and 3/4. Oh no, no, no. Oh, okay. It's 9 pieces. Yeah, that's not gonna hit 3/4. Is it? No, wait, hang on. Right, you get that, yeah, okay. Alright, I'm gonna follow my, since I got quoted on this, we're gonna use the hammer, and the hammer is called Cartesian coordinates. Because I have no idea what else to do. Okay, so y1 and h1. So this is the line called y minus y1 over x is supposed to be equal to the orange guy, which is something. h1 minus y1 over 1/4. Meanwhile, uh, h2 minus y2 over, so y minus y2 over 1 minus x is equal to that. So I can maybe solve. This was it's actually going to work. It's actually going to work because there's two equality cases. That's the problem. Like if it worked for both a right triangle and the hexagon, and it was actually 3/4, like on the dot, this is going to work because you can't. I feel like it's going to work. Okay, I'm not that certain, but I feel like it should work because you can't get that many equality cases otherwise. All right, so oh my god, oh no, uh, h1 minus y1 4 times 1 minus 2x is equal to y2 minus y1. So oh god, this is bad. Uh, oh my god, is there not a cleaner way to do this? Do I just really have to do this? Can I like drop this altitude and say that it's 3/4 of each one? No, I can't. There's no way. I need the 1/4. What? So x is equal to. Oh my god. This is a bad idea to do on stream because I'm gonna mess it up. Okay. Well, okay. Anyways, now that I think about it, actually, I really should have used -1 and 1, right? So that it's a little more symmetric. Sorry. Let me change coordinates. I apologize. We're gonna change these coordinates on the bottom so that they're actually symmetric. I'm gonna put this at -2 and this at 2 and this at -1 and this is 1. And then these 1/4s go away. They're just ones. H2 minus y2. Actually, this is a -1, so I had a sign error already in the previous calculation. And then this is y minus y1 over x plus 2. This is x minus 2. Okay, that way there's no awkward constants. Is this right so far? Yeah, of course you're making me the streamer do the calculation, right? Okay, so there's no 4 anymore. There's going to be some clever dissection proof, and I'm just going to look at it and be sad. Wait, oh, I'm subtracting, so the signs flip anyways. Okay, so subtract. Okay, so h1 plus h2 minus y1 minus y2. This is times x, but then there's a plus 2. Oh, this is horrendous. Okay, do the y's at least? Okay, so lo and behold, oh my, oh jeez, oh freaking, uh, 2h2 minus 2h1 plus y1 minus y2 over h1 plus h2 minus y1 minus y2. Amazing. I don't even want to compute y at that point. Uh, oh lord. Jeez. It's honestly, I think, better for me to eliminate x than to resolve. Okay, whatever. Y is y1 plus x plus 2, which is 4h2. Really? 4h2 doesn't seem good. Did I flip a sign? Hey, if you guys are making me do all the work, at least check my work for me. Like, 2, 2. I don't like that. Why is there 4s? Oh, I guess there has to be a 4 actually. Did I really not flip any signs? You might want to move the apex of your house so it's not on the y-axis. Oh. Okay. 4h2 plus... Wait, I don't... Something's wrong. The dimensions aren't lining up right. Like, I shouldn't be getting y1 squared. That shouldn't happen, right? What did I do wrong? Wait, so something's wrong. That's not supposed to happen. X is supposed to be dimensionless, and oh, I forgot. Okay, this is actually being multiplied on something. That's why. Okay. Oh my god. Hey, this is being. Oh lord. What the frick? Okay. Is there not a better way to do this? This is actually worse than I thought. By like a lot. Minus 3y2. Oh my freaking. Oh, jeez. Oh. Uh. Fine. Yeah, solve. You actually have to solve part A. If you're still not seeing part A, you should let the A equals x over y, B equals y over z, or C equals z over x. Either that or the reciprocal, whichever one works nicer. You should just get rid of the ABC equals 1 like that. Um. Oh no. 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 I'm gonna look at the house picture a little more because I'm actually really annoyed now. Is there really nothing I can do? I mean, this is why. It should be true because we found two distinct equality cases, is my sentiment. Like, because we found two equality cases, I don't see how it would, or it gives, because we found two equality cases and no counterexamples, it gives me a very high degree of confidence. Um, the problem is this computation is so gross. All right, I'm just gonna do it. I will have courage. Oh my god, I hate Cartesian coordinates. I already spent all weekend reading a bunch of Cartesian, and now this is what I get in return. Not weekend, all week. Okay. 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 Now I can expand. Okay, so this y1 square should cancel. All the stuff that's not really symmetric should clean up because I made this whole setup symmetric. Which was a very good thing because otherwise I'd be in real trouble now. Plus 2 y1 y2. This one's okay. And I'm gonna do the thing where once I use a term, I put a check mark on it so I can keep track. This is 4h1h2. That's not going anywhere. Put that at the front. Then y1h1, that cancels. I'll just cancel it. That means h2, y2 should probably cancel as well. Oh, there isn't one to begin with. Okay. Then, h2, y1 has a coefficient. A 5? No, 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 no. That's a 5? That's not good. No, no, I don't believe the 5. Good. This is negative. So, that is, minus 3h2y1 minus 3h1y2. Okay, great. That's why. Yeah, I was like, there's no way there's a 5, because it's supposed to have some degree of symmetry and none of the other coefficients have 5. This is like how you debug your work. If you pick a symmetric setup, when you make mistakes like this, you'll notice, because it doesn't feel right. Geico lizard, don't differentiate, just factor. Okay, so, all in all, I have found the coordinates of x, y are given by 1 over h1 times 2h2 minus 2h1 plus y1 minus y2, comma 4h1 h2 minus 3h2 y1 minus 3h1 y2 plus 2y1 y2. And that doesn't even fit on the screen. Okay. We're trying to prove the green thing is at most 3/4 of the yellow thing in the picture. That's what we're trying to do. Unfortunately, I have no idea how to do it, so I'm using Cartesian. My viewer count has dropped unusually low. I wonder why. Okay, so I'm gonna move all of this junk aside. Because I have the coordinates I need. I hate Cartesian so much. It's the right system to use for this particular setup, which also just means that I'm really sad. Okay, so green area is equal to h1 3/2 h1 plus h2. I hope. It's like 1/2 h1 and then plus h1 plus h2 and then plus h2. And the yellow area by the shoelace formula is equal to some abomination, and I will now compute it. It is 1/2 times, okay, so that's minus 2 y1 0 plus 2 y2 0, not 0, I wish it was 0. And, okay, 2h2 minus 2h1 plus y 1 minus y2 versus 4h1 h2 minus 3h2 y1 minus 3 h1 y2 plus y2 y1 y2 and then 1 where I've divided it out by h1 plus h2 minus y1 minus y2. Coordinate bashing is so bad that my green screen is failing. I don't know why those are related actually. It looks bad, yeah, I agree. Let's go through it anyways because I'm out of ideas. Oh shoot, that's not how. Oh, I was like, why are the dimensions not matching? Sorry, this one here is a copy of the denominator. That's h1 plus h2 minus y1 minus y2. Okay, so I'm gonna first do a thing where I add. Um, no, I'm not. Just kidding. I'm not gonna do that. We're just gonna expand. Um, okay, so if I start with this y1, I get y1. Okay, so that thing, this thing minus that thing, which unfortunately nothing cancels. So 4h1. Oh, the h2 cancels actually, and then minus 3y1, and then minus 2y2 minus y2. Great. And then plus y2 times minus 2h1, so it's minus 4. This should be symmetric, right? Ish. Wait, I think I'm not doing that right. I flipped the sign somewhere. Minus 2h1. Oh, Lord. Okay, and then the last determinant is minus 4 times that abomination. 4h1h2 minus 3h2y1 minus 3h1y2 plus 2y1y2. Oh, jeez. Okay, now let's expand the top. So, there's some y1 squareds that don't go away. It's minus 3y1 squared minus 3y2 squared. This one. No, shoot, there's a minus 4. Why is there a minus 4? Oh my freaking. Oh, jeez. Is there really a minus 4? Like, that's like a minus 10. I really hope this is right, because if not, I have to fix a lot of things. Okay, and then there's an h1, y1. Those are uncancelled. Yeah, this is where I'm like, you really have to finish this, because if I don't finish it, it's a lot of time that doesn't get many points. How do I just hit it? How about I just hit it with a hammer until it dies? Oh, it's a shout out. Okay. Shout out to, how about I just hit it with a hammer until it dies from dotted calculator. I don't know if you guys wanted that for the clip or just because it was funny, but there you go. Okay. Oh, jeez. Is there... Okay, I honestly don't trust this result enough to go with... I'm gonna stare at this. No one's figured out a geometric dissection for this, just at all? In the equality case, y1 and y2 are what? Where did the equality case go? All the way up here. I actually want to move that down. That's in the equality case, y1 and y2 are equal to some. Oh, they're like, ew. That's like some root 3 stuff. Yeah, how do I know how many V-Bucks I have? Look at the bottom of the left of the chat. That number next to the triangle is your V-Bucks. Like, maybe I should just bound, like, can I, like, project the triangle onto the axis or something and increase or decrease its area? Like, there really has to be a better way to do it. There really has to be a better way than this. You don't have a number? Oh, I don't know. Is the thing with f's more tolerable if we want to show that f is concave and then the integral of f is at most 2f minus 1? Well, I mean, that claim is... Oh, actually, that might make a lot of sense. I agree it's less easy to see what to do with, but it also just seems like it should be... Um, there's inequalities that bound this type of thing, right? Mean value type things. Maybe I should just finish the coordinate batch because I got this far. Okay, so we want the green area to be at least 3/4. So what I want is 3/2 h1 plus h2 to be at least okay, all right. Let's just get rid of this thing. I'll put the 4/3 here, and it should be at least. So the area of that trapezoid is 4 to so the 2 plus that thing above, which when I oh my god. Oh my god. No. I really think I'm messing up some signs because I'm getting like the 10 was bad, but now I'm getting a 7. And like the 14 is turned into like a 24. I think I flipped a sign. I think I did like an area that was... I read it clockwise, so everything is flipped. This is a negative area. So I really want it to be the positive one. So I should be subtracting everything from here, and that will make things a little better. This is like y1 squared plus y2 squared. So I'm just going to reverse the denominator now, because the y's are taller than the h's anyways, right? No, they're not. Oh, frick. Well, whatever. Um, okay, so minus y1 squared minus y2 squared for 8 minus 2 y1 y2. Ooh, that's cute. Is that right? Something's not right. That can't be right. Minus 4y1 y2 plus. There's plus. There's plus. And then the y1 h1 terms cancel, and then the h1 h2 terms persist. So okay, we use this one up, I dealt with that one, and the 4 h1 y1s cancel, and the h1 y2s sort of cancel, not really. You get okay. I think that's what you get. I'm off the screen. I'll put that in. Okay, helpful thing that's been true the whole time, if you set all the variables equal to 1, the thing should vanish, which it does. So that's good for us. And so now let's expand both sides. So we want 4h1 plus h2 squared plus to be at least minus y1 minus y2 squared. And then there's a hodgepodge more of things where I get 4y1 plus y2, h1 plus h2, plus 16h1 h2, minus 8h1 y1 minus 8h2 y2. I don't like this. What's going on? 16h1 h2. I really wanted the 8 stuff to cancel, the stuff with the 8s in it. I think I made a mistake earlier, actually. That's not. I think I know what's supposed to happen, and it's not this. So when I go back here, when I said there was 8h1y1, where did those 8s come from? It was, I added 2, 4h1. Those are h1y1s, right? Like I think what's supposed to happen at this point is that these guys are supposed to just cancel out the stuff in the 4s, and you just get an inequality. Like I really think the desired inequality should be this. Like I think this stuff on the left, the far right, was supposed to cancel, and I made a mistake somewhere. So let me backtrack a bit and track down just those terms. 12h2y1. No, it does say. The problem is if I have a 12, that's too big. Like once I get a 12, I think the inequality should be the thing on the green. I really think it should be. Um, but it's not working. And why is it not working? Because I miss something up here? Oh man, we're really not gonna play much braid today. Or I can just stay up late, that's fine too. Did I make a mistake somewhere? Oh wait, no, 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 no. Um, Equality should hold if and only if x is 0. What was, I already forgot what x was. Is that true? Equality holds if and only if x is 0? Why? Well, if equality is going to hold if and only if x is 0, then there's only one thing this could be, which is that it ought to be 2h2 minus 2h1 plus y. Oh, actually, I believe that. Oh, thanks. Okay, I guess I didn't mess up. I guess that's actually just what you get. I think that's what you get. When you clear off the 8s, like this thing is actually equal to 4. I'm gonna get the signs wrong. H1 minus, right, that green is useless. I keep clicking that shade of green and then I'm forgetting. H1 minus H2 Y1 minus Y2. It just factored. Like, someone pointed out the equality case was supposed to be when x is at least 0, and I'm like, oh, I know what that's supposed to be. And it just is the green thing there. Like, with a flip, wait, one of the signs looks wrong. Is it H1 minus? It's the... What, did I screw up? Did I miscopy x? H2, H1, Y1 minus Y2. No, 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 one of the signs is wrong. Damn it. Well, okay, I was subtracting off that thing. Oh, Lord. Hang on, hang on. Minus 12, H1, Y2. Yeah, this one should be this should be 2, 1. and then it's fine. Yeah, I literally just miscopied from the line before. Wait, no. Eh? H1 and H2 have the same sign in the linear expression in the bottom, right? Yeah. Yeah, okay, we're fine. That thing moved there. Okay. And so lo and behold, it's equivalent to this x being yeah. The nice thing is, yeah, someone pointed out I've totally missed that. You have an 8H1 H2 term. That's fine, right? So this should work, right? This is just fine now. Uh, cool. Okay. Yeah, I hate it too. We're definitely missing something. Oh, I hate Cartesian. This is why this is why when someone was asking on the thread, like, how do I learn Cartesian coordinates? I'm like, just learn complex Berry first, because those are the ones where when you practice, you can actually get any mileage, right? Like if you practice Cartesian bashing, first of all, when there's a problem that you're supposed to use that Cartesian will work on, it will be clear because it looks like this. Second of all, it sucks anyways. Like I just feel like there wasn't a way. Like this was already considered like me kind of being a little smart about it. Like I chose -2 versus then +2. Then I used this determinant. I used every factoring trick I had, and it was still like this mess. But anyways, we did it. Oh my god. So the 1/4 3/4 claim was true, and we're missing some nice synthetic proof of it probably. So I want to see what we are missing now. What kind of geo is this? I think it's probably, I don't know. There has to be, yeah. We're just missing it. The stream was, it started as ISL 1-2 level because at that point I still had a lot of people coming. And then as the population slowly whittles down to just the regulars, I up the difficulty. Okay, what am I missing? Oh my gosh. I'm just glad we actually did it. That was a slug. Oh my god, someone pulled off an integral. Oh my god. One of the ALPS posts is actually an integral. And they get 3√3 over 2 pi. Are you serious? The equality case is what you think. Okay, I actually don't see this lemma written out. Incidentally, yeah, okay, I'll put it on the screen. So we totally got baited, and the area thing just works. Like you parameterize it with polar coordinates like we were thinking, and then you throw shoelace at it, and apparently it works. I'm so sad. Does this really work? Are you serious? Oh no. Oh, that's horrible. yi. So if he put it as a yi, and then it's g theta. I can't believe that. That actually works. Oh no. I don't get this line actually. What are theta I? Oh, okay, it's a little trickier. He's like he actually assumes that it is the spokes are equal width apart so that he can get okay, so you have to do equal width spokes. It's not like literally random. And equal spokes will work. Oh no, there's actually Ah. Oh no, this works. Okay, we okay. Rip, rip. I leave this purely algebraic solution to you. Man, I hate Cartesian coordinates. I can't believe the spokes method actually worked. That's actually disgusting. Is number 3 the same as our method? I think it's similar. Yeah, we were right that 3 root 3 over 2 pi was minimal because of this solution. This solution is, oh my god. I'm offended. I think if the problem had changed the constant from 3/4 to 3 root 3 over 2 pi, the problem would have been easier, because now you know you're not supposed to use the tangent lines. Like, if you had used the sharp constant, I would have gone after this one a lot earlier, I think. Maybe I'm just making stuff up. But I really do think that if they had improved the constant to 3 root 3 over 2 pi, then it would have been much more clear that something of this shape, like you know it has to be a rotation argument because you will not get a pi otherwise. So the fact that they gave the elementaries down 3/4 actually made us work much harder and go through many more false paths to make you confident. Well, 3/4 is sort of like, I think 3/4 is probably about as good as you will get with elementary arguments. Yeah, because you're not going to get a pi unless you use some analytic stuff. Like, just you cannot get. I don't think you can get a pi with elementary techniques. So 3/4 is the best of the elementary techniques, and that's why it helped us so much when we restricted ourselves to elementary techniques, right? Because we were going after, you know, basically the moment I saw, I guess I moved it. The moment I saw this, I was like, this is it. This is what I have to go after, because this is where the 3/4 is coming from. This guy over here. Yeah. Wow. What an experience. Okay. See, the thing is, if I start braid, I'm not gonna finish the chapter because I have like half an hour left. Oh jeez. Oh my god.